Dear children, welcome to this channel. In this video, let us see the remaining problems under exercise 4.5. With that, the inverse trigonometric function, this chapter is over. Okay, we have successfully completed this chapter. Fourth problem, prove that the first subdivision is tan inverse of 2 by 11 plus tan inverse of 7 by 24 is equal to tan inverse of 1 by 2. Second subdivision is sin inverse of 3 by 5 minus cos inverse of 12 by 13 is equal to sin inverse of 16 by 65. See, the first one I am going to leave the first one for you. Okay, so do by yourselves because you have to apply directly the formula tan inverse of x plus tan inverse of y. So the left hand side is of the form tan inverse of x plus tan inverse of y, where the product of x and y is less than 1. So just apply the formula and check whether you got this answer tan inverse of 1 by 2. So it is easy. So try this problem by yourselves. Okay. Now let us do the second subdivision. See, look at the left hand side. One is in sin inverse and other term is a cos inverse. See, if both are sin inverse, if both are cos inverse, then you can apply either sin inverse of x minus sin inverse of y or cos inverse of x minus cos inverse of y formula. So you have to change either sin inverse to cos inverse or cos inverse to sin inverse just by constructing a right triangle, as the numbers are not the ratios of specific angles. Okay, but the right hand side is sin inverse, so it is better to convert cos inverse to sin inverse, so that on applying sin inverse of x minus sin inverse of y, you will get the answer in sin inverse. Okay, do you understand this? So what we are going to do, we are going to transform this cos inverse to sin inverse of some number by constructing a right triangle. Okay, so to start with, let us take this cos inverse of 12 by 13 is equal to some theta, which implies cos theta is equal to 12 by 13. So by constructing the right triangle by taking the acute angle to be theta, as cos is 12 by 13, that is adjacent side is 12, hypotenuse is 13, and you know that the Pythagorean triple is 5. Okay, so what would be the opposite side? Opposite side is equal to 5. Therefore this implies sin theta is equal to 5 by 13, and hence theta is equal to sin inverse of 5 by 13. So what is theta? Theta is nothing but cos inverse of 12 by 13. So now we can change this cos inverse of 12 by 13 to sin inverse of 5 by 13 in the given problem. So what is the left hand side? Left hand side is equal to sin inverse of 3 by 5 minus cos inverse of 12 by 13. That is equal to sin inverse of 3 by 5 minus sin inverse of 5 by 13. Okay. Now, what is the formula for sin inverse of x minus sin inverse of y? That is equal to sin inverse of x into root of 1 minus y squared minus y into root of 1 minus x squared. Okay. Now apply this formula here, where x is 3 by 5 and y is 5 by 13. Okay. So that is equal to sin inverse of x, that is 3 by 5, into root of 1 minus y squared. Y squared is 25 by 169. So 25 by 169 minus y, that is 5 by 13, into root of 1 minus x squared. X is 3 by 5, so its square will be 9 by 25. Okay, that is equal to sin inverse of 3 by 5 into root of 169 minus 25 is 144. So 144 by 169 minus 5 by 13 into root of 25 minus 9 is 16. 16 by 25. So that is equal to sin inverse of 3 by 5 into square root of 144 is 12 and that of 169 is 13, minus 5 by 13 into 16, square root is 4 and square root of 25 is 5. Okay. Now that is nothing but sin inverse of 36 by 65 minus 20 by 65. Okay. So that is equal to sin inverse of, so as the denominators are same, 36 minus 20 is 16 divided by 65, which is nothing but our right hand side. Okay. So by transforming this cos inverse of 12 by 13 to sin inverse, and by applying sin inverse of x minus sin inverse of y, we got the corresponding right hand side. Okay. Next, fifth one is prove that tan inverse of x plus tan inverse of y plus tan inverse of z is equal to tan inverse of x plus y plus z minus xyz divided by 1 minus xy minus yz minus xz. So, it is very simple. By look at the left hand side, it is a summation of 3 inverse tan inverse terms. Okay. So, let us apply the formula twice. First for the first 2 terms and then for the resultant and the third term, then you will get the required answer. So, it is very simple. So, let us take the left hand side. Okay. So, first let us apply the formula for the first 2 terms. So, this is nothing but tan inverse of x plus y divided by 1 minus x into y plus tan inverse of z. Okay. Again, you have to apply the formula. So, tan inverse of this, taking this to be x and this is to be y. So, x plus y divided by 1 minus xy plus z, the whole divided by 1 minus x plus y divided by 1 minus xy into z. Okay. So, that is whole divided by. Now, let us simplify and get the required right hand side. Okay. So, by taking LCM in the numerator as 1 minus xy, you will have the numerator as x plus y plus z into 1 minus xy divided by 1 minus xy. Then, for the denominator also, let us take 1 minus xy to the as a LCM. So, it is to be multiplied with this 1. So, 1 minus xy minus of x plus y into z divided by 1 minus xy. Okay. Now, the common denominator get cancelled. That is tan inverse of, then multiply z. So, what happened to the numerator? X plus y plus z minus xyz divided by 1 minus xy, multiplying this z and minus, we have minus xz and minus yz. This is nothing but our right hand side. So, we have proved the LHS and RHS are equal just by applying the formula tan inverse of x plus tan inverse of y twice. Okay. Next, the sixth one is, if tan inverse of x plus tan inverse of y plus tan inverse of z is equal to pi, show that x plus y plus z is equal to x, y, z. See, this is nothing but the continuation of the previous problem. Okay. So, first of all, you have to find out the answer just like the previous one and then equate it to pi and show that the corresponding result. Okay. That is, the corresponding equation is to be proved. Now, take that given tan inverse of x plus tan inverse of y plus tan inverse of z is equal to pi, that is given. Okay. So, let us simplify this just in the previous problem. So, just by taking the first 2 terms and applying the formula, we have tan inverse of x plus y divided by 1 minus xy plus tan inverse of z is equal to pi. Again, applying the formula, we have tan inverse of x plus y by 1 minus xy plus z divided by 1 minus of x plus y divided by 1 minus xy into z. Okay. That is equal to pi. Now, let us move this tan to opposite side. So, simplifying this, we have x plus y plus z into 1 minus xy divided by 1 minus xy minus of x plus y into z, cancelling the common denominator and moving tan to opposite side, we have this is equal to tan pi. Okay. So, that is x plus y plus z minus xyz divided by 1 minus xy minus xz minus yz is equal to, what is the value of tan pi? The value of tan pi is 0. Okay. So, that is equal to 0. So, by cross multiplying this, we have x plus y plus z minus xyz is equal to 0, which in turn implies x plus y plus z is equal to xyz. This is the required result we have to prove. Okay. Next, seventh one, prove that tan inverse of x plus tan inverse of 2x by 1 minus x squared is equal to tan inverse of 3x minus x cube by 1 minus 3x squared, where modulus of x is less than 1 by root 3. Okay. So, this is also very simple because we are going to apply the formula tan inverse of x plus tan inverse of y, as the left hand side represent the same, similar to that. Okay. Now, taking the left hand side, which is equal to tan inverse of, so let us apply the formula. So, what happened to the numerator? X plus 2x divided by 1 minus x squared whole divided by 1 minus x into 2x divided by 1 minus x squared. Okay. So, that is equal to tan inverse of, then taking LCM, we have x into 1 minus x squared plus 2x divided by 1 minus x squared, the whole divided by, again taking LCM 1 minus x squared in the denominator, we have 1 minus x squared minus 2x squared divided by 1 minus x squared. Okay. Now, the common denominator get cancelled, and let us simplify the numerator. So, x minus x cube. So, x plus 2x will be 3x and minus x cube divided by then 1 minus 3x squared. Okay. So, that is our right hand side, and moreover, if for the tan inverse to be exists, the denominator should not be 0. So, that means 1 minus 3x squared must be a positive quantity, that is 3x squared. 1 is greater than 3x squared, or x squared is less than 1 by 3, or modulus of x is less than 1 by root 3. Okay. So, that is our right hand side. So, we have proved LHS and RHS are equal. Moreover, the condition modulus of x is less than 1 by root 3. Then 8th one, simplify tan inverse of x by y minus tan inverse of x minus y by x plus y. So, this is direct application of the formula tan inverse of x minus tan inverse of y. So, it is better you can try by yourselves. Okay. So, do by yourselves. Just have a try on it and find out the answer. Here there is no, the right hand side has been given, not given. So, you have to find out the answer, and let me write down the answer. The answer is pi by 4. Okay. The answer is pi by 4. See here, just apply the formula. The answer should be pi by 4. So, what would be the answer? Finally, you should have tan inverse of 1, and that would be equal to pi by 4. Okay. So, you should get the simplification as 1. So, tan inverse of 1, and that would be equal to pi by 4. Okay. Now, let us see the 9th one. So, in this 9th one, you are going to find out the solution of x. In that 4 subdivisions are given. Let us do one by one. So, what is the first subdivision? Sin inverse of 5 by x plus sin inverse of 12 by x is equal to pi by 2. See, even though the left hand side is of the form sin inverse of x plus sin inverse of y, and if we apply the formula sin inverse of x plus sin inverse of y, you will have some square root. So, it would be somewhat tedious to find out the answer, and therefore, let us apply some other method to do this. Okay. So, by inverse cofunction inverse formula, we have sin inverse of x plus cos inverse of x is equal to pi by 2. So, we know that. Okay. So, we know that sin inverse of x plus cos inverse of x is equal to pi by 2. So, let us apply that here. Okay. So, what happened is, given one, sin inverse of 5 by x can be expressed as pi by 2 minus sin inverse of 12 by x from given hypothesis. Okay. That is from the given condition. Just interchange sin inverse of 12 by x to opposite side. So, according to this formula, this will be equal to cos inverse of 12 by x. Okay. So, sin inverse of 5 by x and cos inverse of 12 by x are now equal. So, let us equate the common quantity to be some theta. Okay. So, this implies that sin theta is equal to 5 by x and cos theta is equal to 12 by x. So after getting sin theta and cos theta in terms of x, it is easy to find out the value of x by using the identity sin squared theta plus cos squared theta is equal to 1. Okay. So sin squared theta plus cos squared theta is equal to 1 implies 5 by x the whole squared plus 12 by x the whole squared is equal to 1. So that is 25 by x squared plus 144 by x squared is equal to 1. So x squared being the common denominator, by adding the numerators we have 169 by x squared is equal to 1, which in turn implies x squared is equal to 169 or x is equal to 13. Okay. By taking square root we have x is equal to 13. Then second one, 2 tan inverse of x is equal to cos inverse of 1 minus a squared by 1 plus a squared minus cos inverse of 1 minus b squared by 1 plus b squared, where a and b are positive quantities. Okay. So here we have cos inverse of, we have one term cos inverse of 1 minus a squared by 1 plus a squared. Okay. So it is that is 1 minus a squared by 1 plus a squared. We have one term in the right hand side. Now look at this. If we replace a by some tan theta, what happened? It will be 1 minus tan squared by 1 plus tan squared. That is nothing but cos 2 theta. So cos inverse of cos 2 theta means easily it can be evaluated as 2 theta, and theta is equal to nothing but tan inverse of a. Okay. So what we are going to do to find out this answer, we are going to represent this a by some tan theta. So put a is equal to tan theta. So this will become cos inverse of 1 minus tan squared theta divided by 1 plus tan squared theta. That is equal to cos inverse of cos 2 theta. So it can be easily evaluated as 2 theta. Now theta is our assumption. So again you have to replace it. So what is theta? Theta is nothing but tan inverse of a. So 2 tan inverse of a. So the value of cos inverse of 1 minus a squared by 1 plus a squared is nothing but 2 tan inverse of a. Similarly, cos inverse of 1 minus b squared by 1 plus b squared is equal to 2 tan inverse of b by taking b is equal to some tan pi. Okay. Then similarly, just by applying taking b is equal to tan pi, we have cos inverse of this will be cos 2 pi, that will be 2 pi, and hence that is nothing but 2 into tan inverse of b. Okay. Now let us substitute in the given formula, that is let us substitute the values in the given equation. What is the given equation? 2 tan inverse of x is equal to cos inverse of 1 minus a squared by 1 plus a squared, that is nothing but 2 tan inverse of a, then minus cos inverse of 1 minus b squared by 1 plus b squared, that is nothing but 2 tan inverse of b. Okay. So that means here you have to write 2 tan inverse of x is equal to cos inverse of 1 minus b squared by 1 plus b squared minus cos inverse of 1 minus a squared and 1 plus a squared by 1 minus b squared by 1 plus b squared implies this one. Okay. Now cancelling throughout by 2, we have tan inverse of x is equal to tan inverse of a minus tan inverse of b. Again apply the formula for this one. So tan inverse of a minus b divided by 1 plus ab. So both side taking tan, we have x is equal to a minus b divided by 1 plus ab. So this is the solution for the given equation. Then the third subdivision is, the given equation is 2 tan inverse of cos x is equal to tan inverse of 2 cosecant x. So from this equation you have to get the value of x. Okay, you have to solve for x. Now you know one formula for 2 tan inverse of x as tan inverse of 2x divided by 1 minus x square. Okay. So this is a formula for 2 tan inverse of x. Now if we replace x by cos x, okay, so what happened? It will be 2 tan inverse of cos x. Okay. So what would be the right hand side? Tan inverse of 2 cos x divided by 1 minus cos squared x. So therefore, okay, just taking x as cos x, replacing x by cos x and applying the formula, we get the value for 2 tan inverse of cos x. Let us simplify this. That is tan inverse of 2 cos x divided by 1 minus cos squared x is sin squared x. Okay. So that is equal to tan inverse of 2. So 1 cos by sin. So if we split this as sin into sin, and by taking cos by sin as cot x and the remaining 1 by sin x cosecant x. Okay. So this can be rewritten as 2 cot x into cosecant x. Now this is given as equal to tan inverse of 2 cosecant x from the given equation. Okay, this is to be equal to tan inverse of 2 cosecant x from the given equation. So as 2 tan inverse of cos x is equal to tan inverse of 2 cosecant x, instead of this we can replace this as tan inverse of 2 cot x into cosecant x is equal to tan inverse of 2 cosecant x. Okay. So by taking tan on both sides, we have 2 cot x cosecant x is equal to 2 cosecant x. And then, so this implies that what would be the value of cot x? Cot x would be nothing but 1. So cot x is equal to 1. So cot x is equal to 1 means we have tan x is also equal to 1. So this 1 can be replaced as tan pi by 4. So tan x is equal to tan pi by 4 means, and this is a trigonometric equation. From that, what would be the solution for this equation? X is equal to n pi plus pi by 4, where n belongs to z. Okay. This is a general solution. Particular value is pi by 4 and the general value is n pi plus pi by 4. Then fourth subdivision in this ninth problem is cot inverse of x minus cot inverse of x plus 2 is equal to pi by 12, where x is positive. So using this equation, you have to find the value of x. Okay. You have to solve for x given this equation. Now you know that tan inverse of 1 by x is equal to cot inverse of x if x is greater than 0 by reciprocal identity. Okay. So let us replace, as x is greater than 0, let us replace cot inverse of x by tan inverse of 1 by x, so that we can apply the formula tan inverse of x minus tan inverse of y here. Okay. So this cot inverse of x minus cot inverse of x plus 2 is equal to pi by 12 now implies tan inverse of 1 by x minus tan inverse of 1 by x plus 2 is equal to pi by 12. Okay. Now let us apply the formula tan inverse of x minus tan inverse of y for the left hand side. So what happened? It would be tan inverse of 1 by x minus 1 by x plus 2 divided by 1 plus 1 by x into 1 by x plus 2, that is equal to pi by 12. Okay. Now this tan inverse will move to opposite side. So let us simplify the term inside the bracket. So taking LCM x into x plus 2, we have the numerator as x plus 2 minus x. Okay. And then divided by x into x plus 2 plus 1, cancelling the common denominator. Okay. So I have cancelled the common denominator x into x plus 2. Then here tan pi by 12. Okay. The right hand side will become tan pi by 12. Now what is pi by 12? Pi is 180. So 180 divided by 12 means it is equal to 15. So that is nothing but tan 15 degree. So let us find out the value of tan 15 degree. So if you keep this as radians, it would be difficult to find out the answer. So let us transform into degrees and find out the answer for this. Okay. So this can be written as tan of 45 minus 30. So let us apply tan of a minus b formula. So tan 45 minus tan 30 divided by 1 plus tan 45 into tan 30. Okay. So what is tan 45? 1, and tan 30 is 1 by root 3 divided by 1 plus 1 into 1 by root 3. So after simplification it would be root 3 minus 1 divided by root 3 plus 1, cancelling the common denominator root 3. Okay. So what happened to this left hand side here? So x and x will get cancelled. So it would be 2 divided by, and then x squared plus 3. Okay. So this will be x squared, plus 2x plus 1, right? That is nothing but 2 divided by, this is equal to x plus 1 the whole square. So what happened? 2 divided by x plus 1 the whole square is equal to root 3 minus 1 by root 3 plus 1. Okay. Now from this equation you have to get the value of x. As here we get a square, perfect square. If you express the right hand side also as a perfect square, the denominator, then it would be easy for us to get the value of x. So usually what we do, we multiply by the conjugate of the denominator. What is the conjugate of the denominator? Root 3 minus 1. If you multiply and divide by root 3 minus 1, we won't get the denominator as a perfect square. So instead of that, let us multiply by divide by root 3 plus 1. Instead of multiplying by dividing by the conjugate, for our convenient, let us multiply and divide by the denominator itself, that is root 3 plus 1. So what happened to the numerator? Applying a plus b into a minus b formula, we have 3 minus 1, that is equal to 2. And here the denominator will be root 3 plus 1 the whole square. So this implies that after cancelling 2 and equating, we have x is equal to root 3. So what is the solution for x? X is equal to root 3. Then last one, find the number of solutions of the equation tan inverse of x minus 1 plus tan inverse of x plus tan inverse of x plus 1 is equal to tan inverse of 3x. So instead of finding the solution, you have to find out the number of solution. That means let us solve this, and counting the number, we can write down the number of solution for the given problem. Okay. Now given that tan inverse of x minus 1 plus tan inverse of x plus tan inverse of x plus 1 is equal to tan inverse of 3x. So here 3 terms are there. Let us move this tan inverse of x to opposite side so that we can simplify these two, and then the other 2 in the right hand side. Okay. So tan inverse of x minus 1 plus tan inverse of x plus 1 is equal to tan inverse of 3x minus tan inverse of x. So let us apply tan inverse of x plus y, tan inverse of x plus tan inverse of y in the left hand side, and tan inverse of x minus tan inverse of y formula in the right hand side. Okay. So what happened to the left hand side? It will be equal to x minus 1 plus x plus 1 divided by 1 minus of x minus 1 into x plus 1. Okay. So here right hand side becomes tan inverse of 3x minus x divided by 1 plus 3x into x. Okay. Now let us simplify the numerator and denominator on both sides. So here minus 1 and plus 1 will get cancelled. X plus x would be 2x, right? And here 1 minus of x squared minus 1, that is 1 minus of x squared minus 1, that is equal to tan inverse of 2x divided by 1 plus 3x squared, right? Now taking tan on both sides, we have 2x divided by 1 minus x squared minus of minus 1 will be plus 1. So that will be 2 minus x squared, and here it will be 2x divided by 1 plus 3x squared. Now cancelling this 2 alone, you should not cancel x, because if the cancellation is possible only if x is not equal to 0. So we don't know whether x is 0 or not. So unless x is equal to 0, we should not cancel this. Okay. So you should only cancel the numerical value 2. Now cross multiply this here. So x into 1 plus 3x squared is equal to x into 2 minus x squared. So multiplying x plus 3x cube is equal to 2x minus x cube. X plus 3x cube is equal to 2x minus x cube. Okay. So we got this. And then after simplifying, we have moving this x cube to opposite side, we have 4x cube, and x minus 2x will be minus x is equal to 0. Now let us factorize this by taking x common outside. So we have 4x squared minus 1 is equal to 0. This implies that either x is equal to 0 or 4x squared minus 1 is equal to 0, or x is equal to 0 or 4x squared is equal to 1, or x squared is equal to 1 by 4, or x is equal to plus or minus 1 by 2. So how many solutions do you get for x? 3 solutions. What are they? 0, plus 1 by 2 and minus 1 by 2. Therefore, what is the number of solutions? So the number of solutions for the given problem is 3. Okay. So see here, we got the value of x as 0. So don't do the cancellation unless you know whether it is a non-zero quantity. So cancellation is possible only if it is a non-zero quantity. That's why we have not cancelled. X is there because it is not known. Dear children, that's all about this chapter, 4th chapter, inverse trigonometric functions. I hope that you have understood the concept well. Okay. And then one more exercise is there, that is 4.6, which is nothing but objective questions. You will see that in the next video.